Simple random sampling. A simple random sample is a sample selected from a population in such a way that every member of the population has an equal chance of being selected, and the selection of any individual does not influence the selection of any other. The selection purely depends on chance. So the personal bias of the investigator will not be present in the sample selected. Random samples may be selected by lottery method B from table of random numbers. A lottery method. Under this method, all items of the universe are numbered or named on separate slips of paper of identical size and shape. This slip are then folded and mixed up in a container. A blindfold selection is then made of the number of slips required to constitute the desired size of sample. While preparing slips, it must be seen that slips are of identical size, shade, color, etc. Otherwise, there is possibility of selecting a particular slip. The selections of items can be made by some mechanical process also. B. Table of random numbers. Using random numbers table, we can select random samples in an easy manner. Several standard tables of random numbers are available. 1. Tippett's random number tables. 2. Fisher and Yates available. 3. Kindle and B.B. Smith tables. 4. C.R. Rouse tables, etc. Tippett's table of random numbers contains series of random digits arranged in rows and columns. Random numbers avoid any bias in selecting the sample. The random numbers are so prepared that they fulfill the criterion of complete randomness. The use of the tables of random numbers involves the following steps. 1. Each number of the population is assigned a number. 2. From some random point of the table of random numbers, the random numbers are read out. The item whose number is identical with the random number read out is selected. 3. The selection of the items is continued till the desired number of items are selected. Since the selection of items in a simple random sample depends entirely on chance, there is no possibility of personal bias. If size of the sample is increased, it will represent the population in a better manner. Assumption in a simple random sample. Following assumptions is made in the selection of a simple random sample. 1. All the items in population have the same chance of being included in the sample. 2. The selection of a particular item in a draw has no influence on the probabilities of selection of any other draw. 3. All the items of sample are selected independently of one another. 4. The selection of each item is in an unbiased manner. Merits and demerits of simple random sampling. Simple random sampling has both advantages and disadvantages. Merits. 1. There is no possibility of personal bias. 2. The simple random sample usually represents population, particularly when the sample size is large. 3. The accuracy of the estimates based on the simple random sampling can easily be assessed, since it's possible to measure the errors of estimation in random sampling. 4. Random sampling ensures the law of statistical regularity, which states that the sample will have the same characteristic of the population if the sample is selected at random. Demerits. 1. It is difficult to have an up-to-date list of all the items of the population to be sampled. 2. If the size of the sample is small, the results may not be reliable. 3. If the item in the universe are not homogeneous, selection of a sample by simple random sample method cannot be adopted. Illustration. Explain how you will select a sample of 100 units from population consisting of 4,212 units, using random numbers. Ands, here n equals 4,212. Identify all the units of the population by a number from 1 to 4,212. Choose 4-figure random numbers table and read out the numbers continuously, vertically or horizontally, starting from any random point. If the number read out is less than or equal to 4,212, but a 4-digit number, then divide it by 4,212 and take the remainder. The unit with the number equal to the remainder may be selected. For example, if a number select is less than 4,212, 403, select it. If the number selected is more than 4,212, say 5,150, then divide the number 5,150 by 4,212 and the remainder in 938. Then the unit 938 is selected. The number once selected may be discarded if it appears again. Thus we select 100 units from the population, which constitute the sample. Example. A set of random numbers, 4-digit, drawn from Tippett's random number table is given below. Complex random sampling designs. Probability sampling under restricted sampling technique may result in complex random sampling designs. These are also known as mixed sampling designs, since both probability and non-probability procedures are applied in this method. Some of the popular complex random sampling designs are I, stratified sampling, E, systematic sampling, E, cluster sampling, IV, multi-stage sampling, V, sequential sampling, etc. Stratified sampling. If the field of inquiry is not homogeneous and contains variety of items, this type of sampling is adopted. In this method, we first divide the population into different subpopulation known as strata, such that items in each stratum are homogeneous. Varied strata, such that items in each stratum are homogeneous in character, and strata between themselves are heterogeneous. From each stratum, items are selected by simple random sample method. For example, if we want to study the consumption pattern of the people in Kerala, Kerala may be divided into a number of zones. From each zone, a sample may be taken at random. This method has the advantage of a simple random sample method, and also the different groups in the population get representation. Stratified sampling method reduces time and expense to a great extent. There is little possibility of any essential group of the population being completely excluded. As the item in each stratum are homogeneous, stratified sampling greater accuracy. Stratified sampling is a mixed sampling, since it consists in itself both purposive sampling and random sampling. Strata are purposely formed and are usually based on past experience and personal judgment of the researcher. Kinds of stratified sampling. 1. Proportional stratified sampling, where number of items taken from each stratum and on the basis of size of each stratum. 2. Disproportionate stratified sampling, where equal number of items are selected from each stratum, irrespective of its size. 3. Stratified weighted sampling, where equal number of items are selected from each stratum, but weights are given to stratum on the basis of its size. Allotting sampling size of different strata. Generally, number of units selected from each stratum is proportional to the number of units of that stratum in the population. For example, a population has 10,000 units and a sample of 1,000 units is to be selected. Then let the population be divided into 4 strata which has 1,000, 2,000, 3,000 and 4,000 units of the universe. Then the number of units to be selected for the sample will be as shown below. From first stratum, x1000 equals 100 units. From second stratum, x1000 equals 200 units. From third stratum, x1000 equals 300 units. From fourth stratum, x1000 equals 400 units. Merits and demerits of stratified sampling. Merits. 1. It is more representative than simple random sample. There is very little possibility of any essential group of the population being completely excluded. 2. It ensures accuracy since each stratum consists of homogeneous items. 3. Stratified samples can be more concentrated geographically. Units from a different strata may be selected in such a way that all of them are located in one geographical area. 4. This will reduce the time and cost. Demerits. If proper satisfaction is not done, the sample will have the effect of bias. If the units selected in a stratum are not homogeneous, the results may not be reliable. In the absence of random selection of items from each stratum which cannot be ensured in many cases, the results are not reliable. Systematic sampling. This method is popularly used in those cases where a complete list of the population from which sample is to be drawn is available. Under this method, the items in the population are included in intervals of magnitude k from every interval selected an item by random sample method. Therefore, between two items selected, there is an interval. For example, when there are 1,000 items in the population and we want to draw a sample of 200 items, then the interval equals 5. From the first interval, select an item by random sample method. Thereafter, the item selected will be with a gap of 5. If first selected is third item, then the items in the sample will be third, eighth, etc. Systematic sampling is a relatively simple technique and may be more efficient than simple random sampling. The time and works involved in sampling by this method are relatively smaller. This method will not give a representative sample. If some hidden periodicities are existing in the universe. If every 50th item produced by a certain production process is defective, then a systematic sample will contain either all defective items or not defective items. Systematic sampling is an easier and less costlier method of sampling and can be conveniently used even in case of large populations. Cluster sampling. Cluster sampling is a random sampling procedure in which the elements for the sample are chosen from the population in groups or clusters rather than singly. Cluster sampling consists in forming suitable clusters of units. All the units in the sample of clusters selected are surveyed. The clusters use pre-existing natural or administrative groups of the population such as schools, colleges, factories, etc. Cluster sampling can be adopted when there would be no reliable list of the units of the population or when it would be very expensive to collect such a list. Cluster sampling is used in many surveys as it is very convenient and less costly. Tribal surveys can be done by cluster sampling technique. Tribes are generally selected in particular areas. Simple random sampling will fail here. In such surveys, few settlements are selected as clusters and all the units of the selected clusters are surveyed. Multi-stage sampling. This is another random sampling procedure carried out in several stages. The population is regarded as made up of a number of first-stage sampling units, each of which is made of second-stage units, etc. At first, the first-stage units are sampled by some suitable method like simple random sampling. Then a sample of second-stage units is selected from each of the selected first-stage units by some suitable method. This procedure is extended. The method has the advantage of being flexible. Multi-stage sampling is applied in big inquiries which cover large geographical area. The advantages of this method: area, 1, easier to administer, 2, large number of units can be sampled for a given cost. Multi-stage sampling is a further development of the principle of cluster sampling. For example, if we want to study the working of cooperative institutions in the country, we can select certain states for study. This is first stage. Then we can select and study the functioning of the institutions there. This represents a two-stage sampling design with ultimate sampling units being clusters of districts. Suppose we select certain town from a select districts and study all institutions there. It is third stage of sampling. Multi-phase sampling. When we want to organize a survey to study the total expenditure incurred by families in a town, we may have only a list of households in the town. So we have to collect data on consumer expenditure from a sample of families selected. If the variation among the households is very large, we may have to select a large sample. The cost for such inquiry may therefore be very large. Therefore, to be more economic, another alternative procedure can be adopted. For this, as a first phase, collect data on some simple characteristic related to consumer expenditure from a sample first selected. Use this information for arrangement, stratification and selection of the second phase sample of the households for the collection of the data on consumer expenditure. This is two-phase sampling. In multi-phase sampling, the first step is to select samples as first phase and from it to collect data on some suitable characteristics like household size. If the main survey is selected in 2 or more phases, then it is described as multi-phase sampling. Sequential sampling. This type of sampling is adopted in acceptance sampling plans and statistical quality control. When a particular lot is to be accepted or rejected on the basis of a single sample, it is known as single sampling. When the decision is to be taken on the basis of 2 samples, it is known as double sampling. When it is based on more than 2 samples, it is multiple sampling. Thus, in this method, samples are taken one after another as desired. The ultimate size of a sample under this technique is not fixed in advance. This type of sampling design is called sequential sampling. Purpose of sampling: judgment sampling, deliberate sampling. Under purpose of sampling, the investigator exercises his discretion in the matter of selecting the items that are to be included in the sample. He deliberately picks up those items which he thinks are the representative of the population. Therefore, in this method, items are selected on the judgment of the researcher. For instance, to study the economic conditions of people in a country, few towns or villages can be deliberately selected which the researcher feels that will represent the country. Under purpose of sampling, therefore, the selection of items to be included in the sample entirely depends upon the direction of the investigator and no formula or principles is followed. If the investigator is wise and unbiased, the sample selected in this manner will be representative. But the chances of personal prejudice and bias are always there. This sampling design is rarely used in large inquiries. This method is not at all scientific. If the researcher is impartial, unbiased and experienced, the results obtained from a purposive sampling will be tolerable. The basic difference between purposive and random sampling, therefore, is that in the former the selection of items to be included in the sample entirely depends upon the discretion of the investigator. In the latter, it is not so, since the chance alone is allowed to determine which items from the population are to be selected. So the personal bias of the investigator will not be present in the sample selected. Purposive sampling is subjective whereas random sampling is entirely objective. Merits of purposive sampling. 1. Representative character. It is possible to make the selection of items as representative as possible. 2. Specific objective. In a purposive sampling, there is specific purpose for which the study is made. 3. Free from bias. It is possible for the researcher to keep himself free from bias and prejudice. 4. Merits of purposive sampling. 5. If the researcher avoids bias and prejudice, even a small sample can be representative. 6. The researcher can select useful units. Therefore, the sample will not include irrelevant items. Demerits. 1. It is not possible for the researcher to have complete idea about the universe. So he may not make a proper selection. 2. If the researcher is biased, the sample results cannot be depended on. Convenience sampling. A convenience sample is obtained by selecting a convenient population. For example, for the study of the spending habits of students, if we select a sample of students from a nearby college, the sample is convenience sample. Quota sampling. This method of sampling is adopted in making surveys of public opinion. Only definite quota of persons in different social classes, different age groups, different regions, etc. are selected for interviews. Convenience sampling methods are sometimes not representative since they are biased and unsatisfactory. Under quota sampling, the interviewers are simply given quotas to be filled from the different strata with some restriction they are to be filled. This type of sampling is convenient and less expensive. Snowball sampling. Snowball sampling is the process of selecting a sample using networks. To start with, a few individuals in a group or organization are selected in the Convenience sampling. A convenience sample is obtained by selecting a convenient population. For example, for the study of the spending habits of students, if we select a sample of students from a nearby college, the sample is convenience sample. Quota sampling. This method of sampling is adopted in making surveys of public opinion. Only definite quota of persons in different social classes, different age groups, different regions, etc. are selected for interviews. Convenience sampling methods are sometimes not representative since they are biased and unsatisfactory. Under quota sampling, the interviewers are simply given quotas to be filled from the different strata with some restriction they are to be filled. This type of sampling is convenient and less expensive. Snowball sampling. Snowball sampling is the process of selecting a sample using networks. To start with, a few individuals in a group or organization are selected and the required information is collected from them. They are then asked to identify other people in the group or organization, and the people selected by them become a part of the sample. Information is collected from them, and these people are asked to identify other members of the group and, in turn, those identified become the basis of further data collection. This process is continued until the required number or a saturation point has been reached, in terms of the information being sought. Interpreting validity of sample result. A sample is selected to find out the characteristics of the universe. Therefore, a sample selected from the universe should be reliable. The reliability of the sample may be tested on the basis of the following aspects. 1. Size of the sample. The size of the sample determines the representative character. So it should be adequate and appropriate. The accuracy of the results derived through the sample can be judged on the basis of the size of the sample selected. 2. Representativeness of the sample. The sample selected for study should represent, by and large, the population in all respects. The results obtained from a sample which is not a true representative cannot be used to generalize the characteristics of the population. 3. Homogeneity of the samples. Samples selected for the study of population must be homogeneous. Otherwise the sample cannot be relied upon. 4. Parallel samples. To examine the reliability of a sample, another sample from the same universe can be drawn and a comparison between the two samples can be made. 5. Unbiasedness in the selection of sample. Sample is to be selected in an unbiased manner. The researcher has to take certain precautions before selecting a sample so that the sample selection is free from bias and prejudice. 6. Sampling within sample. To test the reliability of a sample drawn from a universe, we draw a subsample from the main sample. An intensive study of the subsample can be made. The findings of this study can be compared with the findings of the study of the main sample. This helps the researcher to detect the errors in conclusions. 7. Comparison of measurements of sample with known measures of population. If any measure of the population Quota sampling. This method of sampling is adopted in making surveys of public opinion. Only definite quota of persons in different social classes, different age groups, different regions, etc. are selected for interviews. Convenience sampling methods are sometimes not representative since they are biased and unsatisfactory. Under quota sampling, the interviewers are simply given quotas to be filled from the different strata with some restriction they are to be filled. This type of sampling is convenient and less expensive. Snowball sampling. Snowball sampling is the process of selecting a sample using networks. To start with, a few individuals in a group or organization are selected and the required information is collected from them. They are then asked to identify other people in the group or organization, and the people selected by them become a part of the sample. Information is collected from them, and these people are asked to identify other members of the group and, in turn, those identified become the basis of further data collection. This process continued until the required number or a saturation point has been reached, in terms of the information being sought. Interpreting validity of sample result. A sample is selected to find out the characteristics of the universe. Therefore, a sample selected from the universe should be reliable. The reliability of the sample may be tested on the basis of the following aspects. 1. Size of the sample. The size of the sample determines the representative character. So it should be adequate and appropriate. The accuracy of the results derived through the sample can be judged on the basis of the size of the sample selected. 2. Representativeness of the sample. The sample selected for study should represent, by and large, the population in all respects. The results seen from a sample which is not a true representative cannot be used to generalize the characteristics of the population. 3. Homogeneity of the samples. Samples selected for the study of population must be homogeneous. Otherwise the sample cannot be relied upon. 4. Parallel sample. To examine the reliability of a sample, another sample from the same universe can be drawn and a comparison between the two samples can be made. 5. Unbiasedness in the selection of sample. Sample is to be selected in an unbiased manner. The researcher has to take certain precautions before selecting a sample so that the sample selection is free from bias and prejudice. 6. Sampling within sample. To test the reliability of a sample drawn from a universe, we draw a subsample from the main sample. An intensive study of the subsample can be made. The findings of this study can be compared with the findings of the study of the main sample. This helps the researcher to detect the errors in conclusions. 7. Comparison of measurements of sample with known measures of population. If any measure of a population, for example, average, is known, then it can be compared with the similar measures obtained from a sample. If there is difference in two measures, the reliability of the sample is to be doubted. Sampling and non-sampling errors. Sampling is just a shortcut method, but scientific, for studying a phenomenon. It has several inherent takes or errors, which must be considered by a researcher. Such sampling errors involved in the collection of data are classified into sampling and non-sampling errors. Sampling errors. The errors arising due to drawing inference about the population on the basis of sample is termed sampling error. Even if most care has been taken in selecting a sample, the results derived from a sample study may not be exactly equal to the true value in the population. Hence sampling gives rise to certain errors known as sampling errors. Therefore sampling error is non-existent in complete enumeration. Say, sampling errors may be biased or unbiased. Biased errors are due to chance difference between values included and not included in the sample. The sampling errors occur randomly and they are compensatory type. Therefore their expected value is 0. When the sample size increase, sampling errors decrease. If the population is homogeneous, the sampling errors become smaller. The measure of sampling error is called precision of the sampling plan. Therefore by increasing the population size, precision of the sampling plan can be improved. But increasing the size of the sample results into increase of cost. Therefore effective way of increasing precision is to select a better sampling design which has a smaller sampling error. Non-sampling errors. The errors arising mainly at the stages of ascertaining and processing of data are termed non-sampling errors. They occur both in complete enumeration and sample survey. Non-sampling error can occur at every stage of planning and execution of the census survey. Non-sampling errors may arise from one or more of the following factors. 1. Data collected inadequate and not consistent with the objective of the surveys. 2. Inappropriate statistical unit. 3. Lab-trained and experienced investigators. 4. Errors in presentation and summarization of data. Systematic bias. A systematic bias results from the errors in the sampling procedure. It can be reduced by increasing the sample size. The causes for this type of bias or errors can be detected and corrected. The systematic bias is caused by the following factors. I. Inappropriate sampling frame. If the sampling frame does not represent the universe properly, it will result in systematic error. E. Defective measuring device. If the device is used for measuring values are defective, they will cause systematic error. If the device is used for measuring values are defective, they will cause systematic error. E. Indeterminacy. If individuals are kept under observation, they act in a manner which is different from if they are not kept under observation. Therefore indeterminacy principle may also cause systematic bias. Factors which decide are criteria for selection of a sampling technique. In analysis, two kinds of costs are involved, one the cost of collecting the data and the other, costs of an indirect inference resulting from the data. The cause of indirect inference Indeterminacy. If individuals are kept under observation, they act in a manner which is different from if they are not kept under observation. Therefore indeterminacy principle may also cause systematic bias. Factors which decide are criteria for selection of a sampling technique. In sampling analysis, two kinds of costs are involved, one the cost of collecting the data and the other, costs of an indirect inference resulting from the data. The cause of indirect inference are systematic bias and sampling error. Systematic bias results from errors in sampling procures. Sampling errors are the random variation in the sample estimates derived for the population parameters. While selecting a sampling technique, a researcher must ensure that the technique adopted causes a small sampling error such as inference error. It controls the systematic bias in a better way, and reduces the cost involved in sampling process. Biased and unbiased errors. Error is the difference between the observed value and the true value. Errors may be classified as biased errors and unbiased errors. Biased errors are also called systematic errors. They arise due to bias of the informants or enumerators or defective measurements. Biased errors are either positive or negative. They are cumulative in nature. The unbiased errors occur in the regular course. They are positive as well as negative. They are compensating also. Measurement of errors. Measurement of errors may be absolute or relative. Absolute error. Difference between actual value and the estimated value of an item is called absolute error. Relative error. Relative error is the ratio of the absolute error to the estimated value. Relative error when multiplied by 100 is called percentage error. Review questions. 1. What is meant by population? 2. What is sampling? 3. What are the essential qualities of good sample? 4. Distinguish between census and sampling methods of collecting data. 5. Why sampling necessary in many statistical inquiries? 6. What are the merits and demerits of sample survey? 7. Distinguish between population and sample. 8. What is simple random sampling? 9. Explain stratified sampling. 10. What is in complex random sampling? 11. What is multiphase sampling? 12. Define simple random sampling and explain a method of drawing such a sample from population. 13. What are random sampling numbers? How do you use them for the selection of a sample from a given population? 14. Explain the law of statistical regularity and law of inertia of large numbers. 15. What is systematic sampling? 16. What is meant by cluster sampling? 17. Explain sequential sampling. 18. Explain the criteria for the selection of a sampling procedure. 19. What is a sample design? 20. What is the purpose of sampling? 21. Distinguish between random sampling and deliberate sampling. 22. What is sampling error? 23. What is non-sampling error? Unit 13. Determination of sample size. One of the critical factors influencing research and statistical investigation is sampling and sample size. Sampling should be sufficiently reliable to estimate and examine certain values of the whole population. A housewife takes a few boiling rice from a boiling pot to check its cooking. She is ensuring the cooking of the whole pot, i.e., the whole population on the basis of a few sample grains. Thus, emerged the concept of sampling. Sampling is a tool which helps to know the characteristics of the population. Sampling is defined as the process of drawing representative number of items for collecting information to infer about the population. This unit focuses on principles governing sample size, factors influencing sample size and approaches to determination of sample size. Principles of sampling. Sampling is reliable because it is based on two universally accepted principles or theories. Law of statistical regularity. The principle states that if samples are drawn at random from a population, it is likely to possess the characteristics of the population. In other words, samples will be statistically regular if samples are regular. Law of inertia of large numbers. According to this principle, large numbers are relatively more stable than small numbers. It is difficult to move or change large numbers. Large numbers have consistency. Sample. A finite subset of population, selected from it with the objective of investigating its properties, is called a sample of that population. A sample is representative part of the population. It ideally purports to be a minute model or replica of the population. For example, when we want to study the life of electric bulbs produced by a company, we select some bulbs and study their length of life. This selected number is the sample. Characteristic of a good sample, essential qualities of a good sample. A good sample is that which fulfills the objectives of a research. Sample, in order to be a good sample, must have the following characteristics. 1. Representative. A good sample should be truly representing the universe. A good sample is one which possesses by and large all characteristics of the population. This can be achieved only if the sample is drawn by adopting the proper principle of selecting samples. If the population are not homogeneous, then the sample should be so selected that it contains items of different section of the population so that sample is true representative of the population. 2. Example. Only if the sample possesses required number of units selected from the population, it will possess a representative character. A sample should not be very small. If it is very small, it cannot represent the population. The size of the sample should be decided properly. 3. Free from bias and prejudice. The selection of sample should be free from bias and prejudice. Otherwise, samples may not be dependable. 4. Subject matter. The sample selected should fill the needs of the subject matter under study. Sample selected should serve the purpose. All types of sampling will not suit all kinds of inquiry, so the sample selected should be one which suits the situation. 5. Based on experience. The sample selected should be based on the past experience and practical experiences of the investigators who have done similar research work. Size of the sample. The number of sampling units selected from the population is called the size of the sample. If the size of the sample is small, it may not represent the universe adequately. If the sample size is very large, it may require more time and money for investigation. Hence, the sample size should not be too small or too large. It should be optimum. Optimum size ensures efficiency, representativeness, reliability, and flexibility. Factors influencing sample size. Sample size is the number of items included in a sample. This is a decision factor in accurately estimating population parameters. Sampling precision depends more on sample size, and not on proportion of population sampled. In sampling analysis, vital questions are, how large the sample should be. If the sample size is too small, estimation may be inaccurate. If it is too large, heavy costs may be incurred. Following factors will decide the size of the sample. 1. Determined by the nature of the study. If an intensive study is to be made, sample of large size shall not be useful. A sample of a small size is more convenient. The nature of the universe also determines the size of the sample. If the universe is homogeneous, a small size sample will yield required result. If the universe is not homogeneous, a small sample will not be of much use. 3. Number of classes to be formed of the population is a criterion for determining the size of the sample. Sample size can be small if the number of classes is not large in number. 4. Precision is another criterion for determining the size of the sample. The size is so determined that the results obtained from the sample achieves precision. 5. The size of the sample depends on the size of the population also. If the population is large, sample also is to be large. 6. The selection of items also influences the size of the sample. Approaches in sample size decision. There are two alternative approaches for determining size of the sample. First approach is to specify the precision of estimation desired and then to determine sample size and necessary to ensure it. The second approach uses cost of additional information against expected value of additional information. The first approach is capable of solving a mathematical solution, and as such is a frequently used technique of determining sample size. The limitation of this technique is that it does not consider the cost of gathering information. The second approach is theoretically optimal, but is rarely used because of difficulty in measuring the value of information. The second approach employs estimation guesswork. Therefore, we shall concentrate here on the first approach. Determining sample size, confidence level approach. When a sample study is made, sampling errors are bound to occur, and this can be controlled by selecting sample of adequate size. Precision level must be specified along with confidence level. Sample size can be determined considering such level of confidence, standard deviation, and expected error. Sample size for infinite population. In case of infinite population, number of elements within the population and indefinite are uncertain. Normally populations belong to this group. Sample size equals n equals z2x a2n2. Where n equals sample size. Equals value of significance level equals 1.96 or 2.58 a equals standard deviation. Equals expected error. Sample size for finite population. Finite population, number of elements within population n, will be certain and given, along with standard deviation and expected error. N equals Z2x Na2. N1 E2 plus CUX A2 where n equals sample size. Z equals value of significance level equals 1.96 or 2.58 A equals standard deviation. E equals expected error. N equals number of items in population. Calculation of sample size when standard deviation is given x 13.1. Production controller estimates that average production per day is 100 with standard deviation 4.8. He expects an error of 3. Items he should include in a sample, at 95% level of confidence. Q equals 4.8 E equals 3 Z equals 1.96 N equals equal to 2x Q2 equals 1.962 by 4.82 equals 9.834 taken as 10 E2 Q2. XX 13.3, 22. Sample size for estimating weight of 5,000 milk packets with variance of weight 4 grams, an expected error of 0.8 grams, at 99% level of confidence. N equals 5,000 Z equals 2.58 Q equals 2 E equals 0.8 N equals N equals Z2x and Q2 equals 2.58 2x 5,000 x Z2 equals 40.95 taken as 41. N1 E2 plus C2 x Q2 4,999 x E2 plus 2.58 2x C2 x 13.3. Determine the number of items to be included in 99% level of confidence, with standard deviation to an expected error of 0.8. Q equals 2 E equals 0.8 Z equals 2.58 N equals N equals Z2x Q2 equals 2.58 2x C2 equals 41.28 taken as 41. Estimation approach and calculation of sample data. How big a sample should I select? What should be my sample size? And how many cases do I need? These are the most common questions asked. Basically, it depends on what you want to establish. In undertaking research is the main determinant of the level of accuracy required in the results, and this level of accuracy is an important determinant of sample size. How qualitative research is the main focus is to explore or describe a situation, issue, process or phenomenon. The question of sample size is less important. You usually collect data till you think you have reached saturation point in terms of discovering new information. Once you think you are not getting new data from your respondents, you stop collecting further information. Of course, the diversity or heterogeneity is what you are trying to find out about plays an important role in how fast you will reach saturation point. And remember, the greater the heterogeneity or diversity in what you are trying to find out about, the greater the number of respondents you need to contact to research saturation point. In determining a sample for quantitative studies and in particular for cause and effect studies, you need to consider the following. At what level of confidence do you want to test your results, findings or hypotheses? With what degree of accuracy do you wish to estimate the population parameters? What is the estimated level of variation, standard deviation, with respect to the main variable you are studying, in the study population? Answering these questions is necessary regardless of whether you intend to determine the sample size yourself or have an expert do it for you. Size of the sample is important for testing a hypothesis or establishing an association, but for other studies the general rule is the larger the sample size, the more of your sample. The results in selecting a sample, within the constraints of your budget, lie in the way you select your elements so that they effectively and adequately represent your sampling population. To illustrate this procedure, let us take the example of a class. Suppose you want to find out the average age of the students within an accuracy of 0.5 of a year, that is, you can tolerate an error of half a year on either side of the true average age. Also assume that you want to find the average age within half a year of accuracy at 90% confidence level, that is, you want to be 95% confident about your findings. There are a number of formulae for calculating samples. One among them is n equals 1.96xq, where n equals sample size. 1.96 E value for 5% level of significance, q equals standard deviation n. E equals expected error there and only one unknown quantity in the above equation, that is q. Now the problem is to find the value of q, without having to collect data. This is the biggest problem in estimating the sample size. Because of this, it is important to know as much as possible about the study population. The value of q can be estimated by any one of the following methods. 1. Statistical guessing. 2. Consulting an expert. Obtaining the value of q from previous comparable studies, or 4. Carrying out a pilot study to calculate the value. Now in the classroom example, we can assume that the q or standard deviation equals 1 year. The n equals 1.96x q equals 1.96x1 equals 3.92, that means n equals 16. To determine the average age of the class at a level of 95% accuracy, assuming q equals 1 year, with 1/2 year of error, a sample of at least 16 students is necessary. Now assume that instead of 95%, if you want to be 99% confident about the estimate age, tolerating an error of 1/2 year. The n equals 2.14 x1 equals 5.15 n equals 26.54 equals 27. Q hence, if you want to be 99% confident and are willing to tolerate an error of 1/2 year, you need to select a sample of 27 students. So you can calculate the sample size with varying values of standard deviation, or remember the golden rule: the greater the sample size, the more accurately your finding will reflect the true picture. In the above formulae, standard deviation of population were given or assumed. But in many cases it may not be given or is not available or cannot be assumed. So we have not yet taken the sample and are in the stage of deciding the size of the sample, we cannot calculate standard deviation of population. If we have an idea about the range difference between highest value and lowest value, we can estimate standard deviation of population is below. XX 13.3, 1.1. So you're estimating wages of workers in a village, and it is learned that there is difference of 40 rupees between the highest wage 640 and lowest wage 600. We know that 1.96 Q covers 95% of items in a study. It means 3.92 Q covers the given range of population. Thus given range equals 3.92 x Q equals 40. Q equals given range equals 40 equals 10.30, i.e., about 10 workers. 3.92. The obtained standard deviation 10 can be utilized for estimating sample size. Sample size for estimating proportion. Estimating proportion, the number of elements in a sample is a decision factor which must be specified beforehand. Besides, the expected precision and the confidence level also should be considered. Number of items to be included in a sample for estimating proportion value will be n equals z2 x p x q. E2 where n equals sample size. S equals value of significance level equals 1.96 or 2.58 Q equals standard deviation. E equals expected error. X 13.4. The size of sample, to be drawn from a population, to estimate percent effective, within 2% of true value, with 95% level of confidence. For this 100 items were selected and obtained 2 defectives. E equals 0.02 Z equals 1.96 P equals 0.02 Q equals 0.98 N equals. N equals Z2 X P X Q equals 1.962 by 0.02 by 0.02. E 0.022 equals 188.24 taken as 188. X 13.5. In a hotel, 5 out of 100 visitors stay overnight. The management want to be 95% confident that population percentage to be estimated with plus 3% of true value. What should be minimum sample size? E Z equals 1.96 P equals 0.05 Q equals 0.95 N equals. Z2 X P X Q equals 1.962 by 0.05 by 0.05 equals 202.75 or 203 visitors E 2.032. Review questions and exercises. 1. Sampling a critical factor in researches. 2. Explain non-sampling errors. 3. Define sample. 4. What is sample size? 5. Explain optimum sample size. State the determining factors in sample data. Describe steps in determining sample size for mean test. 8. What is the procedure in deciding sample size for proportion? 9. What are the characteristics of a good sample? 10. How is sample size determined for finite population? 11. How is sample size determined if standard deviation is not given? 12. Determine the size of sample for estimating true mean of the population of size 5,000, on the basis of the following. Population variance equals 4, level of confidence equals 99%, estimated error equals 4. What would be the size of sample for estimating mean of the population, if standard deviation equals 15. Estimated error equals 6. Level of confidence equals 99%. 14. Determine a population of 5,000 units to estimate the percentage of defectives on the basis of 3% defectives in the sample within 0.05 units of its true value. Level of confidence desired is 95%. 15. A sample drawn from a population to estimate the percent effective within 2% of the true value with 95% level of confidence, on the basis of 3% effective in the sample. Unit 14. Data collection. Introduction. Task of data collection begins after a research problem has been defined and research design plan chalked out. While deciding about the method of data collection to be used for the study, the researcher should keep in mind 2 types of data, viz., primary and secondary. Primary data are those which are collected afresh and for the first time, and thus happen to be original in character. The secondary data, on the other hand, are those which have already been passed through the statistical process. The researcher to decide which sort of data he would be using, thus collecting, for his study accordingly he will have to select one or the method of data collection. The methods of collecting primary and data differ since primary data are to be originally collected, while in case of secondary data the nature of data collection work is merely that of compilation. We describe the different methods of data collection, with the pros and cons of each method. Experiments and surveys. We collected primary data during the course of doing experiments in an experimental research. An experiment refers to an investigation in which factor or variable under test is isolated and its effects measured. In an experiment the investigator measures the effects of an experiment which he conducts intentionally. Once we do research of the descriptive type and perform surveys, whether sample surveys or census surveys, then we can obtain primary data either through observation or through direct communication with respondents in one form or another or through personal interviews. Survey refers to the method of securing information concerning the phenomena under study from all or a selected number of respondents of the concerned universe. In a survey, the investigator examines experiment and a survey can be depicted as under. Tools of collecting primary data. There are a number of tools or methods of collecting primary data, particularly in surveys and descriptive researches. Some important methods are described below. Observation method. The observation method is the most commonly used method especially in studies relating to behavioral sciences. In a way we all observe things around us, but this sort of observation is not scientific observation. Observation is a tool in the method of data collection for the researcher, when it serves a formulated research purpose, is systematically planned and recorded and is subjected to checks and controls on validity and reliability. Under the observation method, the information is sought by way of investigators' own direct observation without asking from the respondent. For instance, in a study relating to consumer behavior, the investigator instead of asking the brand of wristwatch used by the respondent, may himself look at the watch. Methods of observation. 1. The advantage of the method is that subjective bias is eliminated, if observation is done accurately. The main advantage of the method is that subjective bias is eliminated, if observation is done accurately. 2. Secondly, the information obtained under this method relates to what is currently happening, it is not complicated by either the past behavior or future intention or attitudes. 3. Thirdly, this method is independent of respondents. Willingness to respond and is such as relatively less demanding of active cooperation on the part of respondents as happens to be the case in the interview or the questionnaire method. 4. This method is particularly suitable in studies which deal with subjects or respondents who are not capable of giving verbal reports of their feelings for one reason or the other. Demerits of observation. However, observation method has various limitations. Firstly, it is an expensive method. 2. Secondly, the information provided by this method is very limited. 3. Thirdly, sometimes unforeseen factors may interfere with the observational task. 4. The fact that some people are rarely accessible to direct observation creates obstacle for this method to collect data effectively. Precautions in observation. While using this method, the researcher should keep in mind certain aspects. What should be observed? How the observation should be recorded. How the accuracy of observation can be ensured. Structured and unstructured observation. In case the observation is characterized by a careful definition of the units to be observed, the style of the recording the observed information, standardized conditions of observation and the selection of pertinent data of observation, then the observation is called a structured observation. But when observation to take place without these characteristics to be thought of in advance, the same is termed as unstructured observation. Structured observation is considered appropriate in descriptive studies, whereas in an exploratory study the observational procedure is more likely to be relatively unstructured. Participant and non-participant observation. We often talk about participant and non-participant types of observation in the context of studies, particularly of social science. This distinction depends upon the observer sharing or not sharing the life of the group he is observing. If the observer observes by making himself, more or less, a member of the group he is observing so that he can experience what the member of the group experienced, the observation is called as the participant observation. But when the observer observes as a detached emissary without any attempt on his part to experience through participation what others feel, the observation of the type is often termed as non-participant observation. When the observing in such a manner that his presence may be unknown in the people he is observing, such an observation is described as disguised observation. Controlled and uncontrolled observation. Sometimes we talk of controlled and uncontrolled observation. If the observation takes place in a natural setting, it may be termed as uncontrolled observation, but when observation takes place according to definite pre-oral range plans, involving experimental procedure, the same is then termed controlled observation. In non-controlled observation, no attempt is made to use precision instruments. The major aim of this type of observation is to get a spontaneous picture of life and persons. It has a tendency to supply naturalness and completeness of behavior, allowing sufficient time for observing it. But in controlled observation, we use mechanical or precision instruments as aids to accuracy and standardization. Such observation has a tendency to supply formalized data upon which generalization can be built with some degree of assurance. The main pitfall of non-controlled observation is that of subjective interpretation. There's also the danger of having the feeling that we knew more about the observed phenomena than we actually do. Generally, controlled observation takes place in various experiments that are carried out in a laboratory or under controlled conditions, whereas uncontrolled observation is resorted to in case of exploratory researches. Interview method. The interview method of collecting data involves presentation of oral verbal stimuli and reply in terms of oral verbal responses. This method can be used through personal interviews and if possible, through telephone interviews. Personal interview. Personal interview method requires a person known as the interviewer asking questions generally in a face-to-face contact to the other person or persons. At times the interviews may also ask certain questions and the interviewer responds to these, but usually the interviewer initiates the interview and collects the information. This sort of interview may be in the form of direct personal investigation or it may be indirect oral investigation. In the case of direct personal investigation, the interviewer has to collect necessary information personally from the sources concerned. He has to be on the spot and has to meet people from whom data have to be collected. This method is particularly suitable for intensive investigations. But in certain cases it may not be possible or worthwhile to contact directly the persons concerned or on account of the extensive scope of inquiry, the direct personal investigation technique may not be used. In such cases an indirect oral examination can be conducted under which the interviewer has not cross-examined other persons who are supposed to have knowledge about the problem under investigation and the information obtained is recorded. Most of the commissions and committees appointed by the government carry on investigations make use of this method. Types of structured interviews. The method of collecting information through personal interviews is usually carried out in a structured way. As such we call them structured interviews. Such interviews involve the use of a set of predetermined questions and of highly standardized techniques of recording. Thus, the interviewer in a structured interview follows a rigid procedure laid down asking questions in a form and order prescribed as against it. The unstructured interviews are characterized by a flexibility of approach to questioning. Unstructured interviews do not follow a system of predetermined questions and standardized techniques of recording information. In a non-structured interview the interviewer is allowed much greater freedom to ask in case of need, supplementary questions or at times he may omit certain questions if the situation so require. He may even change the sequence of questions. He has relatively greater freedom while recording the responses to include some aspects and exclude others. But this sort of flexibility results in lack of comparability of one interview with another and the analysis of unstructured responses becomes much more difficult and time-consuming than that of the structured responses obtained in case of structured interviews. Unstructured interviews also demand deep knowledge and greater skill on the part of the interviewer. Unstructured interview, however, happens to be the central technique of collecting information in case of exploratory or formulative research studies. In descriptive studies, we quite often use the technique of structured interview because of its being more economical, providing a safe basis for generalization and requiring relatively lesser skill on the part of the interviewer. Focused interview. We may as well talk about focused interview, clinical interview and the non-directive interview. Focused interview is meant to focus attention on the given experience of the respondent and its effects. Under it the interviewer has the freedom to decide the manner and sequence in which the questions would be asked and has also the freedom to explore reason and motives. The main task of the interviewer in case of a focused interview is to confine the respondent to a discussion of issues with which he seeks conversance. Such interviews is used generally in the development of hypotheses and constitute a major type of unstructured interviews. The clinical interview is concerned with broad underlying feelings or motivations or with the course of individual's discretion. In the non-directive interview, the interviewer's function is simply to encourage the respondent to talk about the given topic with a bare minimum of direct questioning. The interviewer often acts as a catalyst to a comprehensive expression of the respondent's feelings and beliefs and of the frame of reference within which such feeling and beliefs take on personal significance. Despite the variations in interview techniques, the major advantages and weaknesses of personal interviews can be enumerated in a general way. The chief merits of the interview method are as follows. Telephone interviews. This method collecting information consists in contacting respondents on telephone itself. It is not a widely used method, but plays important part in industrial surveys, particularly in developed regions. The chief merits of such a system are: 1. It is more flexible in comparison to mailing method. 1. It is more flexible in comparison to mailing method. 2. It is faster than other methods, i.e., a quick way of obtaining information. 3. It is cheaper than personal interviewing method. Here the cost per response is relatively low. 4. Recall is easy. Callbacks are simple and economical. 5. There is a higher rate of response than what we have in mailing method. The non-response is generally very low. 6. Replies can be recorded without causing embarrassment to respondents. 7. Interviewer can explain requirements more easily. 8. At times, access can be gained to respondents who otherwise cannot be contacted for one reason or the other. 9. No field staff is required. 10. Representative and wider distribution of sample is possible. This system of collecting information is not free from demerits. Some of these may be highlighted. 1. Into respondents for considered answers. Interview period is not likely to exceed 5 minutes in most cases. 2. Survey are restricted to respondents who have telephone facilities. 3. Extensive geographical coverage may get restricted by cost considerations. 4. It is not suitable for intensive surveys where comprehensive answers are required to various questions. 5. Possibility of the bias of the interviewer is relatively more. 6. Questions have to be short and to the point. Probes are difficult to handle. Precautions in interview. Interviewing is an art and one learns it by experience. However, following points may be kept in view by an interviewer for eliciting the desired information. 1. Interview must plan in advance and should fully know the problem under consideration. He must choose a suitable time and place so that the interviewee may be at ease during the interview period. For this purpose, some knowledge of the daily routine of the interviewee is essential. 2. Interviewer's approach must be friendly and informal. Initially, greeting in accordance with the cultural pattern of the interviewee should be exchanged and then the purpose of the interview should be explained. 3. All possible efforts should be made to establish proper rapport with the interviewee. People are motivated to communicate when the atmosphere is favorable. 4. Interviewer must know that ability to listen with understanding, respect and curiosity is the gateway to communication, and hence must act accordingly during the interview. For this, the interviewer must be intelligent and must be a man with self-restraint and self-discipline. 5. To the extent possible there should be a free-flowing interview and the questions must be well phrased in order to have full cooperation of the interviewee. But the interviewer must control the course of the interview in accordance with the objective of the study. 6. In case of big inquiries, where the task of collecting information is to be accomplished by several interviewers, there should be an interview guide to be observed by all so as to ensure reasonable uniformity in respect of all salient points in the study. Collecting of data through questionnaire. This method of data collection is quite popular, particularly in case of big inquiries. It is being adopted by private individuals, research workers, private and public organization and even high governments. In this method a questionnaire is sent, usually by post, to those persons concerned with a request to answer the questions and return the questionnaire. A questionnaire is mailed to respondents who are expected to read and understand the questions and write down the reply in the space meant for the purpose in the questionnaire itself. The respondents have to answer the question on their own. The method of collecting data by mailing the questionnaires to respondents is most extensively employed in various economic and business surveys. The merits claimed on behalf on this method are as follows. 1. There is low cost even when the universe is large and is widely spread geographically. 2. It is free from the bias of the interviewer. Answers are in respondents' own words. 3. Respondents have adequate time to give well thought out answers. 4. Respondents have adequate time to give well thought out answers. 5. Large samples can be made use of and thus the results can be made more dependable and reliable. The main demerits of this system can also be listed here. 1. Low rate of return of the duly filled in questionnaires. Bias due to no response is often indeterminate. 2. It can be used only when respondents are educated and cooperating. 3. The control questionnaire may be lost once it is sent. 4. There is inbuilt inflexibility because of the difficulty of amending the approach once questionnaires have been dispatched. 5. There is also the possibility of ambiguous replies or omission of replies altogether to certain questions. Interpretation of omissions is difficult. 6. It is difficult to know whether willing respondents are truly representative. 7. This method is likely to be the slowest of all. Before using this method, it is always advisable to conduct pilot survey for testing the questionnaires. In a big inquiry the significance of pilot survey is felt very much. Pilot survey is in fact the replica and rehearsal of the main survey. Such a survey, being conducted by experts, brings to the light the weaknesses if any, of the questionnaires and also of the survey techniques. From the experience gained in this way, improvement can be effected. Main aspects of a questionnaire. Quite often questionnaire is considered as the heart of survey operation, hence it should be very carefully constructed. If it is not properly set up, then the survey is bound to fail. This fact requires us to study the main aspects of a questionnaire viz. The get general from, question sequence and question formulation and wording. Researchers should note the following with regard to these three main aspects of a questionnaire. General form. So far as the general form of a question name is concerned, it can either be structured or unstructured questionnaire. Structured questionnaires are those questionnaires in which there are definite, concrete and predetermined questions. The questions are presented with exactly the same wording and in the same order to all respondents. Resort is taken to this sort of standardization to ensure that all respondents reply to the same set of questions. The form of the question may be either closed, i.e. of the type yes or no, or open, i.e. inviting free response, but should be stated in advance and not constructed during questionnaires, one in which all questions and answers are specified and comments in the respondents' own words are kept to the minimum. When these characteristics are not present in a questionnaire, it can be termed unstructured or non-structured questionnaire. More specifically, we can say that in an unstructured questionnaire, the interviewer is provided with a general guide on the type of information to be obtained, but the exact question formulation is largely his own words to the extent possible. In some situation tape recorders may be used to achieve this goal. Structured questionnaires are simple to administer and relatively inexpensive to analyze. The provision of alternative replies, at times, helps to understand the meaning of the question clearly. But such questionnaires have limitations too. For instance, wide range of data that too in respondents' own words cannot be obtained with structured questionnaires. They are usually considered inappropriate in investigations where the aim happens to be to probe for attitudes and reasons for certain actions or feelings. They are equally not suitable when a probe line is being first explored and working hypotheses sought. In such situations, unstructured questionnaires may be used effectively. Then on the basis of the results obtained in pretest testing before final use, operation from the use of unstructured questionnaires, one can construct a structured questionnaire for use in main study. Question sequence. In order to make the questionnaire effective and to ensure quality to the replies received, a researcher should pay attention to the question sequence in preparing the questionnaire. A proper sequence of questions reduces considerably the chance of individual questions being misunderstood. The question sequence must be clear and smoothly moving, meaning thereby that the relation of one question to another should be readily apparent to the respondent, with questions that are easiest to answer being put in the influence the attitude of the respondent and in seeking his desired cooperation. The opening questions should be such as to arouse human interest. The following type of should generally be avoided as opening question in a questionnaire. 1. Questions that put too great a strain on the memory or intellect of the respondent. 2. Questions of a personal character. 3. Questions related to personal wealth, etc. Following the opening questions, we should have questions that are really vital to the research problem, and a connecting thread should run through successive questions. Ideally, the question sequence should conform to the respondent's way of thinking. Knowing what information is desired, the researcher can rearrange the order of the questions. This is possible in case of unstructured questionnaire, to fit the discussion in each particular case. But in a structured questionnaire, the best that can be done is to determine the questions EQCAS with the help of a pilot survey, which is likely to produce good rapport with most respondents. Relatively difficult questions must be relegated towards the end so that even if the respondent decides not to answer such questions, considerably information would have already been obtained. Thus, question sequence should usually go from the general to the more specific, and the researcher must always remember that the answer to a given question is a function not only of the question itself, but of all previous questions as well. For instance, if one question deals with the price usually paid for coffee and the next with reason for preferring that particular brand, the answer to this latter question may be couched largely in terms of PNCE differences. Question formulation and wording. With regard to this aspect of questionnaire, the researcher should note that each question must be very clear, for any sort of misunderstanding can do irreparable harm to survey. Questions should as low be impartial in order not to give a biased picture of the true state of affairs. Questions should be constructed with a view to their forming a logical part of a well throughout tabulation plan. In general, all questions should meet the following standards: A. Should be easily understood. B. Should be simple, i.e. should convey only one thought at a time. C. Should be concrete and should conform as much as possible so the respondent's way of thinking. For instance, instead of asking, "How many razor blades do you use annually?" the more realistic question would be to ask, "How many razor blades did you use last week?" Concerning the form of questions, we can talk about two principal forms, viz. Multiple choice question and the open-end question. In the former, the respondent selects one of the alternative possible answers put to him, whereas in the latter he has to supply the answer, in his own words. The question with only the possible answers, usually yes or no, can be taken as special case of the multiple choice question, or can be named as a closed question. There are some advantage and disadvantage of each possible form of question. Multiple choice or closed questions have the advantages of easy handling, simple to answer, quick, and relatively inexpensive to analyze. They are most amenable to statistical analysis. Sometimes, the provision of alternative replies helps to make clear the meaning of the question. But the main drawback of fixed alternative questions is that of putting answers in people's mouths, i.e., they may force a statement of opinion on an issue about which the respondent does not in fact have any opinion, on an issue about which the respondent does not in fact have any opinion. They are not appropriate when the issue under consideration happen to be a complex one, and also when the interest of the researcher is in the exploration of a process. In such situations, open-ended questions which are designed to permit a free response from the respondent rather than one limited to certain stated alternatives are considered appropriate. Such questions give the respondent considerable latitude in phrasing a reply. Getting the replies in respondent's own words is, thus, the major advantage of open-ended questions. But one should not forget that from an analytical point of view, open-ended questions are more difficult to handle, leading to problems of interpretation, comparability, and interviewer bias. In practice, one rarely comes across a case when one questionnaire relies on a form of questions alone. The various forms complement each other. As such, questions of different forms are included in one single questionnaire. For instance, multiple choice questions constitute the basis of a structured questionnaire, particularly in a mole survey, but even there, various open-ended questions are generally inserted to provide a more complete picture of the respondent's feelings and attitudes. Researcher must pay proper attention to the wordings of questions, since reliable and meaningful returns depend on it to a large extent. Since words say likely to affect, they should be properly chosen. Simple words, which are familiar to all respondents, should be employed. Words with ambiguous meaning must be avoided. Caution must also be exercised in the use of phrases which reflect upon the prestige of the respondent. Question wording, in no case, should bias the answer. In fact, question wording and formulation is an art and can only be learned by practice. Essential of a good questionnaire. 1. To be successful, questionnaire should be comparatively short and simple, i.e., the size of the questionnaire should be kept to the minimum. 2. Questions should proceed in logical sequence, moving from easy to more difficult questions. Personal and intimate questions should be left to the end. 3. Technical terms and vague expressions capable of different interpretation should be avoided in a questionnaire. 4. Questions may be dichotomous, yes or no answer, multiple choice alternative answers listed, or open-ended. The latter type of the respondent, for instance, a question designed to determine the consumption of particular material, may be asked first in terms of financial expenditure and latter in terms of weight. 5. The control questions, thus, introduce a cross-check to see whether the information collected is correct or not. 6. Questions affecting the sentiments of respondents should be avoided. 7. Adequate space for answers should be provided in the questionnaire to help editing and tabulation. There should always be provision for indications of uncertainty, e.g., do not know, no preference, and so on. 8. Bright directions with regard to filling up the questionnaire should invariably be given in the questionnaire itself. 9. Finally, the physical appearance of the questionnaire affects the cooperation. 8. Bright directions with regard to filling up the questionnaire should invariably be given in the questionnaire itself. 9. Finally, the physical appearance of the questionnaire affects the cooperation the researcher receives from the recipients, and is such an attractive-looking questionnaire, particularly in mail survey, is a plus point for enlisting cooperation. The quality of the paper, along with its color, must be good so that at the attention of recipients. Nowadays, the usage of internet is quite popular in collecting data. Questionnaires are sent through emails to randomly or purposely selected people. Their email IDs can be taken from some other surveys. The trend of paid surveys had also started. There are some websites which pays for filling the questionnaires. Collection of data through schedules. This method of data collection is very much like the collection of data through questionnaire, with little difference which lies in the fact that schedules, or proforma containing a set of questions, are being filled in by the enumerators who are specially appointed for the purpose. The enumeration along with schedules go to respondents, put to them the questions from the proforma in the order the questions are listed, and record the replies in the space meant for the same in the proforma. In certain situations, schedules may be handed over to respondents and enumerators may help them in recounting their answers to various questions in the said schedules. Enumerators explain the aims and objects of the investigation and also remove the difficulties which any respondent may feel in understanding the implications of a particular question or the definition or concept of difficult terms. This method requires the selection of enumerators for filling up schedules or assisting respondents to fill up schedules, and as such enumerators should be very carefully selected. The enumeration should be trained to perform their job well, and nature and scope of the investigation should be explained to them thoroughly so that they may well understand the implications of different questions put in the schedule. Enumerators should be intelligent and must possess the capacity of cross-examination in order to find out the truth. Above all, they should be honest, sincere, hardworking, and should have patience and perseverance. Difference between questionnaire and schedule. Both questionnaire and schedule are popularly used methods of collecting data in research surveys. There is resemblance in the nature of these two methods, and this fact has made many people to remark that from a practical point of view, the two methods can be taken to be the same. But from the technical point of view there is difference between the two. The important points of difference are as under. 1. The questionnaire is generally sent through mail to informants to be answered as specified in a covering letter, but otherwise without further assistance from the sender. The schedule is generally filled out by the research worker or the enumerator, who can interpret questions when necessary. 2. To collect data through questionnaire is relatively cheap and economical, since we have to spend money only in preparing the questionnaire and in mailing the same to respondents. Here no field stall required. To collect data through schedules is relatively more expensive, since considerable amount of money has to be spent appointing enumerators and in importing training to them. Money is also spent in schedules. 3. Non-response is usually high in case of questionnaire, as many people do not respond and many return the questionnaire without answering all questions. Bias due to non-response often remains indeterminate. As against this, non-response is generally very low in case of questions. But there remains the danger of interviewer bias and cheating. 4. In case of questionnaire, it is not always clean as to who replies, but in case of schedule the identity of respondent is known. 5. The questionnaire method is likely to be very slow, since many respondents do not return the questionnaire in time despite several reminders, but in case of schedules the information is collected well in time as they are filled in by enumerators. 6. Personal contact is generally not possible in case of the questionnaire method, as questionnaires are sent to respondents HVY post, who also in turn return the same by post. But in case schedules, direct personal contact is established with respondents. 7. Questionnaire method can be used only when respondents are literate and cooperative, but in case of schedules the information can be gathered even when the respondents happen to be illiterate. 8. Wider and more representative distribution of sample is possible under the questionnaire method, but in respect of schedules there usually remains a difficulty in sending enumerators over a relatively wider R. 9. Risk of collecting incomplete and wrong information relatively more under the questionnaire method, particularly when people are unable to understand questions properly. In case of schedules, the information collected is generally complete and accurate, as comprators can remove the difficulties, if any, faced by respondents incorrectly understanding the questions. As a result, the information collected through schedules is relatively more accurate than that obtained through questionnaires. 10. The success of questionnaire method lies more on the equality of the questionnaire itself, but in the case of schedules much depends upon the honesty and competence of enumerators. 11. In order to attract the attention of respondents, the physical appearance of questionnaire must be quite attractive, but this may not be so in case of schedules, as they are to filled by enumerators and not by respondents. 12. Along with schedules, observation method can also be used, but such a thing is not possible while collecting data through questionnaires. Guidelines for constructing questionnaire schedule. The researcher must pay attention to the following points in constructing an appropriate and effective questionnaire or schedule. 1. The researcher must keep in view the problem he is to study, for it provides the starting point for developing the questionnaire schedule. He must be clear about the various aspects of his research problem to be dealt with in the course of his research project. 2. Appropriate form of questions depends on the nature of information sought, the sample respondents, and the kind of analysis intended. The researcher must be constructed with a view to their forming a logical part of a well-thought-out tabulation plan. The units of enumeration should also be defined precisely so that they can ensure accurate and full information. 3. Rough draft of the questionnaires should be prepared, giving due thought to the appropriate sequence of putting questions. Questionnaires are scheduled previously drafted, if available, may as well be looked into as this stage. 4. Researcher must invariably re-examine, and in case of need may revise the rough draft for a better one. Technical defects must be immediately scrutinized and removed. 5. Pilot study should be undertaken for pre-testing the questionnaire. The questionnaire may be edited in the light of the result of the pilot study. 6. Questionnaires must contain simple but straightforward directions for the respondents so that they may not feel any difficulty in answering the questions. Innovative methods of data collection. Let us consider some other innovative or modern methods of data collection particularly used by business house in modern times. They are extensively employed in market researches. Warranty cards. Warranty cards are usually postal-sized cards which are used by dealers of consumer durables to collect information regarding their products. The information sought is printed in the form of questions on the warranty cards, which is placed inside the package along with the product with a request to the consumer to fill in the card and post it back to the dealer. Distributor or stone audits. Distributors or store audits are performed by distributor well as manufacturers through their salesmen at regular intervals. Distributors get the retained stores audited through salesmen and use such information to estimate market size, market share, and seasonal purchasing pattern, and so on. The data are obtained in such audits not by questioning but by observation. For instance, in case of a grocery stone audit, a sample of stores is visited periodically and data are recorded on inventories on hand either by observation or copying from store records. Store audits are invariably panel operations, for the derivation of sales estimates and compilation of sales trends by stores are their principal raison d'etre. The principal advantage of this method is that it offers the most efficient way effect on sales of variations of different technique of in-store promotion. Pantry audits. Pantry audit technique is used to estimate consumption of the basket of goods at the consumer level. In this type of audit, the investigator collects an inventory of types, quantities, and prices of commodities consumed. Thus in pantry audit data recorded from the examination of consumers' pantry. The usual objective in pantry audit is to find out what types of consumers buy certain brands. The assumption being that the contents of the pantry accurately portray consumers' preferences. Quite often, pantry audits are supplemented by direct questioning relating to reason and circumstances under which particular products were purchased in an attempt to relate these factors to purchasing habits. A pantry audit may or may not be set up as a panel operation, since a single visit is often considered sufficient to yield an accurate picture of consumers' preference. An important limitation of pantry audit approach is that, at times, it may not be promotion devices produce a marked rise in sales. Consumer panels. An X section of the pantry audit approach on a regular basis is known to maintain detailed daily records of their consumption, and the summary is made available to investigator on demands. In other words, a consumer panel is essentially a sample of consumers who are interviewed repeatedly over a period of time. Mostly consume panels are of two types, viz. The transitory consumer panel. A transitory consumer panel is set up to measure the effect of a particular phenomenon. Usually such a panel is conducted on a before and after basis. Initial interviews are conducted before the phenomenon has taken place to find out the consequent changes that might have occurred in the consumer's attitude. It is a favorite tool of adverting and of social research. A continuing consumer panel is often set up for an indefinite period with a view to collect data on particular aspect of consumer behavior over time. Generally, all periodic intervals are maybe meant to serve as a general-purpose panel for researchers on a variety of subjects. Such panels have been used in the area of consumer expenditure, public opinion, and radio and TV listenership, among others. Most of these panels operate by mail. The representativeness of the panel is relative to the population and the effective panel for researchers on a variety of subjects. Such panels relative to the population and the effect of panel membership on the information obtained after the two major problems associated with the use of this method of data collection. Use of mechanical devices. The use of mechanical devices has been widely made to assess psychological impact and attitude. One of the prominent devices was psychogalvanometer. Motion picture camera and audiometer are the principal devices so far developed and commonly used by modern big business houses, mostly in the developed world, for the purpose of collecting the required information. Eye cameras are designed to record the focus of yes of a respondent on a specific portion of a sketch or diagram or written material. Such information is useful in designing advertising material. Pupil-metric cameras record dilation of the pupils as a result of a visual stimulus. The extent of dilation shows the degree of interest aroused by the stimulus. Psychogalvanometer is used for measuring the extent of body excitement as a result of the visual stimulus. Motion picture cameras can be used to record movement of body of a buyer while deciding to buy consumer goods from a shop or big store. Influence of packaging or the information given on a label would stimulate a buyer to perform certain physical movements which can easily be recorded by a hidden motion picture camera in the shop, as four walls. Audiometers are used by some TV concerns to find out the type of programs as well as stations preferred by people. A device is fitted in the television instrument itself to record these changes. Such data may be used to find out the market share of competing television stations. Projective techniques. Projective techniques, or what are called as out interviewing techniques, for the collection of data have been developed by psychologists to use projection of respondents for inferring about underlying motives, urges, intention which are such that the respondent either resists to reveal them or is unable to figure out himself. In projective techniques, the respondent in supplying information tends unconsciously to project his own attitudes or feeling on the subject under study. Projective techniques play an important role in motivational researches or in attitude surveys. Use of these techniques requires intensive specialized training. In such techniques, the individual's own view, his personality structure, his needs, tensions, etc. In the context of some pre-established psychological conceptualization of what the individual's responses to the stimulus mean. We may now briefly deal with the important projective techniques. Word association tests. These tests are used to extract information regarding such words which have maximum association. In this sort of test, the respondent is asked to mention the first words that comes to mind, ostensibly without thinking, as the interviewer reads out each word from a list. If the interviewer says cold, the respondent may say hot and the like ones. The general technique is to use a list of as many as 50 to 100 words. Analysis of the matching words supplied by the respondents indicates whether the given word should be used for the contemplated purpose. The same idea is exploited in marketing research to find out the quality that is mostly associated to a brand of a product. A number of qualities of a product may be listed and informants may be asked to write brand names possessing one or more of these. This technique is quick and easy to use, but yields reliable results when applied to words that are widely known and which possess essentially one type of meaning. This technique is frequently used in advertising research. Sentence completion tests. These tests happen to be an extension of the technique of word association tests. Under this, informant may be asked to complete a sentence, such as, persons who wear khadi are. To find association of khadi clothes with certain personality characteristic. Several sentences of this type might be put to the informant on the same subject. Analysis of replies from the same informant reveals his attitude toward that subject, and the combination of these attitudes of all the sample members is then taken to reflect the views of the population. This technique permits the testing not only of words, as in case of word association tests, but of ideas as well, and thus helps in developing hypotheses and in the construction of questionnaires. This technique is also quick and easy to use, but it often leads to an analytical problem, particularly when the response happens to be multidimensional. Story completion tests. Such tests are a step further wherein the researcher may contrive stories instead of sentences and ask the informants to complete them. The respondent given just enough of story to focus his attention on a given subject, and he is asked to supply a conclusion to the story. Verb projection tests. These are the tests wherein the respondent is asked to comment on or to explain what other people do. For example, why do people smoke? Answers may reveal the respondent's own motivation. Pictorial techniques. There are several pictorial techniques. The important ones are as follows. Thematic apperception test, TAT. TAT consists of a set of pictures. Some of the pictures deal with ordinary day-to-day events, while others may be ambiguous pictures of unusual situations that are shown to respondents forms the basis for the investigator to draw inferences about their personality structure, attitudes, etc. Rosenzweig test. This test uses a cartoon format wherein we have a series of cartoons with words inserted in balloons above. The respondent is asked to put his own words in an empty balloon space provided for the purpose in the picture. From what the respondents write in this fashion, the study of their attitudes can be made. C. Rorschach test. This test consists of 10 cards having print of inkblots. The design happens to be symmetrical but meaningless. The respondents are asked to describe what they perceive in such symmetrical inkblots, and the responses are interpreted on the basis of some predetermined psychological framework. This test is frequently used, but the problem of validity still remains a major problem of this test. Holtzman inkblot test, HIT. This test from W. H. Holtzman is a modification of the Rorschach test explained above. This test consists of 45 inkblot cards, and not 10 inkblots as we find in case of Rorschach test, which are based on color movement, shading, and other factors involved in inkblot perception. Only one response per card is obtained from the subject or the respondent, and the responses of a subject are interpreted at 3 levels of from appropriateness. For responses are interpreted for knowing the accuracy F or inaccuracy F of respondents, shading and color for ascertaining his affectional and emotional needs, and movement responses to assessing the dynamic aspects of his life. Special features or advantages. Firstly, ILEC's relatively constant number of responses per respondent. Secondly, it facilitates studying the responses of a respondent to different cards in the IEAF norms of each card instead of lumping them together. Thirdly, it elicits much more information.